The second problem is given f(xy) equal to 1 over capital A multiple y squared multiple x, and y bigger equal to 1, and 1 over y smaller than x smaller than y. And there's 4 problems need to solve. First one is draw the non-zero definition regional of fxy, and second one is find capital A so that fxy is a valued joint density function, and third one is find and draw the Magritte density functions fx and fy. The last question is verify fx and fy are valued density functions. So here's the graph it gives us from the Cruise to Homework 5. They also gave us the graph for the problem 1 and the problem 2. Also the problem 2. So for the problem 1, there's 2 slopes. One, the black one is graph x equal to y, and the blue one is x equal to y over 1 over y. And for the problem 2, we know that fxy equal to 1 over capital Y multiple y squared multiple x, y bigger equal to 1, and 1 over y smaller than x smaller than y. And so we can get integral from 1 to infinity, and the multiple integral from 1 over y to y, and is 1 over capital A multiple y squared multiple x, delta x and delta y, and equal to integral from 1 to infinity 1 over capital A multiple y squared multiple integral from 1 over y to y, and 1 over x delta y, and we can get 2 over capital A multiple integral from 0 to infinity we the power of negative w and delta w, and we can get minus a negative 2 over capital A integral from z to infinity w delta e over the power of negative w, and we can get capital A equals to 2. And for the problem 3 and the problem 4, we can get that the equation fy equal to integral from negative infinity to infinity fxy delta x equal to in y over y squared, and 1 smaller equal to y smaller than infinity, and 0 otherwise. And I show the graph under it. There's a slope from 1 and goes to the infinity, and then integral from 1 to infinity in y over y squared delta y equal to 1. Yes, fy is value probability density function, and fx equal to integral from negative infinity to infinity fxy delta y when x smaller than x 0 smaller than x smaller than 1, fx equal to integral from infinity to 1 over x, and 1 over z multiple 2 square multiple x delta y equal to 1 over 2, and when x smaller than infinity, fx equal to integral from infinity to x, and equal to 1 over 2 multiple y square multiple x delta y equal to 1 over 2 multiple x square. And I show the graph in the end. There's a slope from y 1 over 2 starts, and when get to the x axis is 1 going down and to the infinity.